Okay, so hello everyone. Let's go ahead and get started. I don't know what level of proficiency you guys are at in terms of Java and programming, so please let me know if any of this is too hard. Because today's topic is a little bit complicated. Um, yeah. So first thing we're gonna talk about is 2019 December contest problem number 3. Hopefully you guys all read it. If you guys didn't, I'll give you a basic gist, but I really urge you to read this on your own. But the idea is you got 8 cows, right? And you're trying to well, the farmer likes to milk them in a certain order. So you just want to make sure that they're milked in a specific order, based on the conditions that they give you here, right? That's really about it. After some thinking, hopefully, I don't think that, I don't know. I like to usually give my students a chance to think for themselves, like about 10 to 20 minutes. I usually give them about 10, but hopefully you guys give yourself about 10 minutes to come up with some version of the solution, okay? Here, I want to talk about the brute force solution. So, sorry, I have to keep watch of the time because I might go over. Here, you have to realize that it's often easier to just come over with every single combination of the order of the cows that he milks them. The term for that is called permutation, right? So if a combination is I can choose any number of these, a permutation is how am I going to order this, right? So if you guys understand permutation, then you can really get a lot of these permutation problems down. It's actually a whole entire section in USACO guide. So I kind of wanted to give you guys a sort of visual image on how I like to think about permutation. Now my code is a little bit complicated. Chian's teacher's code is really nice. I can give you a version of her permutation as well, and you guys can adapt to that. But I really want you guys to understand permutation. So that's why I kind of spent some time drawing up this sort of image here. Because the idea that I wanted to go over is let's talk about the first easiest version of permutation. This one I'm not going to draw the visual for it, but basically you just do a for loop nested multiple times, right? Hopefully that's not too much of a problem to understand. You can actually see that in the imagery that I'm about to show you anyways, how a for loop could also work as well. But because we're using the idea of recursion to do permutation, I feel like this concept is really hard to understand. So I want you guys to understand that this is using recursion here, okay? And the way I like to think about recursion is you're handing off a job to a sort of like a slave. Now this slave can duplicate himself, right? So what I imagined was, okay, let's say we want to come up with the permutation for the number 231, which, simply put, we're just coming up with the permutation for 1, 2, and 3, right? So how would you do this work? Well, the first thing you have to do is understand what one permutation does, okay? So what I kind of drew over here is a little robot. And what he does is he basically just let's say he was filling in for this spot over here. He's just going to fill it in with the sum number between 1 and 3. That's all he's going to do. Okay, that's his job. So for the robot 1, he's going to be in charge of filling in the first slot. Okay, so all each robot does, just focus on this robot. Don't focus on these other slots. Just focus on what this one robot is trying to do. This one robot is trying to fill up this number, then this number, then this number. That's only his job, right? And I'll show you guys the sort of like the English version of what I mean by this in just a second. But his job is to sort of go down the list one by one, okay? And all he's going to do is as soon as he makes a spot available, let's say he chose 2 at some point, he will pass his job to the next robot, right? Now, the way this robot works is because we chose 2, we do have to get rid of this 2 over here. because that was already taken up from the previous robot. But otherwise, this robot does the exact same thing. These robots are identical clones of each other. So this robot will do the 1, and then it will do the 3. So let's say it did the 3. That leaves with the robot doing this robot. Oops, sorry, 1 second. This robot, of course, the slots of 2 and 3 were already taken up. So this robot only can do 1. As you can see, that's kind of like how permutation works, is you're making each robot do scan through each one, and you're going to see it be passed down, okay? Now, I know this visualization doesn't really do that kind of justice, but I kind of want to throw this out there, okay? Because the code itself actually is pretty difficult to understand, even though it's really easy to memorize. And I'll show you some easier looking codes, but it's kind of hard to understand, right? So I have this text file here I kind of want to give you guys. I'm not going to have you guys memorize this, don't worry. Okay, I don't expect you guys to fully understand it. But I'm giving you guys this version because if you actually look at it, it looks a lot like ACSL's recursive function style thing. And I really urge you guys to, as you guys are programming this, if you're confused about the algorithm, I really want you guys to try this as if it was an ACSL problem, right? So let's look at this sort of idea here. Your job is to basically solve f of current order is an empty array and k is equal to 0. So what does this mean? So if k is cow.length, which is 0, so it's not cows.length, right? Then we're just going to do this one over here. For every available cow, we're going to insert a cow into current order from cows. In short, if you had to look at it in code, we're going to add into current order the next available cow, okay? And we're going to make that cow unavailable for future calls. Then we're going to do that recursive idea. So you're going to do this, solve for this. After you recurse it, you're going to make that cow re-available, and then you're going to remove that. Okay, how much time am I working with? It's about good. So if you guys are going, I have no idea what this guy is talking about, right? So if you guys are thinking that, right, let me actually kind of walk through like 1 or 2 steps, okay? So let's say cows was something simple like ABC. Okay, so let's not do something crazy here. Let's just try ABC. And I want you guys to, again, when you guys are coding this on your own, try actually doing this as if it was an ACSL problem. I think that's going to be really helpful. When I was trying to understand recursion, I didn't do it the ACSL way, but I actually drew out the tree every single time until I understood it, right? These things don't come intuitively, unless you're getting it intuitively. That's good for you, I guess. But if it doesn't, then you need to spend that time grinding it out, understanding it. And so I really want to hopefully build that intuition for you guys. So let's go ahead and try this out anyway. So we get the cows ABC, and we want to try out current order is an empty array, so we can just do that. And k is 0. What is this? Well, we don't do the first one. For every available cow, so for, let's say, A, what do we do for A? We insert a cow into current order. So current order, let's just call it CO, is A. We insert this A into current order. Then we're going to make that cow unavailable for future calls. You can imagine sort of putting a red X on that if you want to. Right? Then we're going to call f of what? So put this on a different column. Actually, don't put it below because this is going to get long. F at A. And if it says k plus 1, so k is 0, so it's going to become k is 1. Okay. And repeat this process for the next available cow is B. So we're going to say for B and then for C. So don't forget that later on, you do have to eventually, after you finish all of this, go back to doing for B and then for C as well for this guy here. So it is a very long process, right? Which is why I'm just doing A, B, and C, right? Now you'll see that CO then gets inserted A, then B. So I kind of want to give this to you guys as an exercise. Really try this code out by hand. This recursive thing, I hopefully this makes sense to you guys if you guys did it by hand. And yeah, try to explain recursive functions in like 10 to 20 minutes. Probably didn't make a lot of sense for a lot of you guys, but I will be giving this out. And I really want you guys to try this by hand. That's really all I want you to do. Okay. And yeah, my version of the code, let me open up Eclipse here. Should I delete this? I'll delete this because I have the source code already. So let's go ahead and actually program this and see what it looks like. I don't know if you guys have a specific format for the USACO stuff. I'm gonna stay away from the format, but let me know if you guys prefer the format and this is confusing, okay? Actually, yeah, chat's right there. Cool. Okay. So let's see here. First things first, I'll actually just worry about the input first. The thing about this problem is we need to create these cows first, okay? What's nice about the permutation algorithm that I just gave you, which is inserting something and then running the recursion and then pulling it back out. If you put this in order, the permutations come out in the order. So if you do 1, 2, and 3 as your original order, then it will actually come out in order. It'll be 1, 3, 2 next, and then 2, 1, 3 next. It'll just keep increasing, right? That's a really nice thing about this permutation algorithm. So let's go ahead and not only create this array, but let's go ahead and put this in order, okay? So I think a good place to start is here. And please let me know if you guys prefer the format. I will not be sticking to the format, okay? But if there is a format, I will stick to that. Go ahead and create a scanner for our new file here, which is going to be lineup.in, lineup.out. If you haven't already, go ahead and create those first by going right-click, new file, lineup in, lineup.out. Hopefully you guys know all this stuff. Let me know if any of this is. This does require us to do a throws IO exception. I'm just going to do everything here, throws IO exception here. Okay, let's go ahead and, oh shoot, wait, I said I'm going to do this first. My bad. We should probably set up cows first. For the cows, I had a version of the code where I basically take this and just kind of make it an array by doing this. You just need to make an array of containing those things, okay? My version basically took this and then just split it based on space because I don't want to write the commas and the quotes again every single time. Just typing wise, I felt like this just was easier on my oh, I got to do this. I got to make sure all these syntax is correct. I don't need to worry about that. I just make one log string separated by spaces and it pretty much works. And I said it'd be nice if you actually sorted it. It's not sorted because there's a BU here when there's a BE, so we do need to sort it. It's a nice little function called arrays.sort. This does lexicographic sorting. If you don't know what that means, I think it's alphabetic. I think that's the best term for alphabetic, but I don't know if that's 100% correct, but that's the way you can understand that. Lexicographic is alphabetic. So yeah, that's how we just create our array. We just use split and do that. It's very simple, nothing too hard. Yeah, so let's go ahead and figure out the let's get the input here. Yeah, one thing I realized was that this thing is constant throughout the whole thing, so there's no real reason to do anything too complicated. Let's talk a little bit about this condition actually before we proceed. It's actually really simple. All we need to care about is this X and this Y, right? So it'd be really nice if we had a piece of data containing just these two values, like next to each other as like this pair. So I'm not going to do something really complicated. I am going to use a two-dimensional array. If you have issues with two-dimensional arrays, you guys should really work on those. If you see a two-dimensional array, look for them. I feel like those things are really useful for like coming up with data structures, right? I'm going to make this two-dimensional array called conditions. And if you don't know much about two-dimensional arrays and you have questions, please let me know. But, oh, shoot, we have to read n. I completely forgot about this n here. Go ahead and read n. That's just in dot. Now, if you're wondering why I'm choosing to do parse int instead of next int, I think rule of thumb is you don't want to mix next line with next stuff, like token stuff. So since I know I'm just going to be reading this whole entire line, I'm just choosing to do the next line. Next line, I mean. So we're going to read n different lines here, n different conditions, right? And all I really did here was just make my pair equal to in.nextLine dot split, and then space must be milked. It's a nice little already two cow pair right there. So we can just add that into our conditions. And that's really it with that one. So I'm going to end that close. Done with that stuff. Okay. So I feel like up to here is pretty straightforward. Let me know if it's confusing at all. Need an explanation. I am reading the chat as I'm doing this. So if you guys just talk in the middle of it, I will answer it. Okay. How much time am I looking with? 10 minutes? Cool. I think we can go ahead, and the first thing that I want to do here is come up with the permutation algorithm at this point, right? My version does use this, but there are easier versions than this, I think, but this is just very dependent on this right here, okay? So the idea here is if I take my current order and I specify a k, right? And I do need to pass in a conditions thing here. But once I specify all of these here, actually, maybe it's easier if I just put conditions up there. Whatever. We'll just stick with this for now. Yeah, so let's do this if here. Right. I'm just basing it off of this. There's a basic if else here. If this is true, so if k is equal to cows dot, and we can stop. Right. Otherwise, it's not. We're gonna talk about the checking part in just a second, because that one's also a whole thing. But really all we're doing here is we're checking the thing. Okay, so that's really all that is. We just check the current permutation. Okay. Now for, oh, by the way, if this wasn't clear, sorry, I should have probably mentioned this before. This k value is telling you what position we are in. That's the important thing about understanding this k is it's not just there to just be like, oh, let's see how many things are there, right? It actually tells us what our position is in the thing. So if k equals 0, that's currently, it's not just saying current order is of size 0. It's saying that's actually where we should be putting our thing. Okay. So what we're going to do here is we're going to check for every available cow next, right? So we can actually just do this simply by going through everything in cows. But the way we're going to check if they're available is we're going to use a little bit of a trick here. For those of us that are in my class, I do like these little tricks. So let me know if this is kind of confusing or if it's a little bit off the mark. I use the idea of null here. Strings, right? So the nice thing about strings is you can make them null. So if I make this cows null, I'm going to say that's not available, right? So if it's not null, then it's available. That's what this basically is saying, right? So if this cow is available, I'm going to insert this cow into the current cow. So we're going to do the current order at position k is equal to cows at I. So it's the next available cow using our for loop. It's put into our kth position. Now we got to make that cow unavailable in the future. So we're going to set cows at I equal to null. You see, that's the trick that I'm using here, is if it's not null, then it's available, right? This is where our recursion happens. We're going to call permute, and we're going to pass in the entire thing. We'll talk about the return statement in just a second. That's a little bit complicated as well. But the thing is, we're going to actually pass k plus 1. And then we do have to keep continuing past the conditions just because of the way I defined it. Sorry about this. I should have fixed this in my previous code. Okay, so let's say we did this. One thing that we should probably check is if it failed or not, right? So what we'll say is null is also a type of failure. So if this comes out null, right, then we failed, right? So if it succeeded, then it's not null, right? So if it succeeded, then what I'm going to do is I'm actually going to return directly the current order. We're not going to reset anything. We're just going to return it directly. Okay, so again, if this is confusing, please do the ACSL thing that I showed you. I would even add the if statement return part here to make it a little bit more clear how that works. Okay, with the ACSL way. Otherwise, what we're going to do is we're going to remove this cow from K, although we do have to set it into cows first. Actually. So before we set it to null, we lose the data. Let's go ahead and set cows of I back into the whatever we set it to, right? And then we do cur order. So we change this back into the thing. And so we basically undo the entire thing and we just move on to the next cow. That's really what this permutation is. So if this is any point confusing, I'm going to be posting up different permutation codes that she sent me. Hopefully those will make sense. But again, I really want you guys to try this out by hand, right? Until you guys get that intuition, right? I think that's priority than getting this correct. Okay. We're almost done. That's fine. Checking, I might need to look at the source code here for a bit, but I think it's really useful if we just check one condition for the entire order. What I mean by that is, let's make a simple function called check order, and or let's just call it check condition, right? And so we're going to go to our entire order that we just did, and we're going to check if it matches this pair of conditions, right? This condition pair, okay? And that's actually really easy because all you need to do is just scan through the whole thing. And if you find that cow, make sure that cow is next to on the left or right. So hopefully this part isn't too complicated. I'm just going to go through the whole thing. You guys, I think you guys know how to do search algorithms pretty easily. Let me know if you guys are confused by this version because I'm skipping over it. Whoops, sorry, that's from a C#. If my current, let's actually first check this. What I'm going to do is I'm going to check the one right before it first. If current order at I dot equals whatever condition is on the first one, and current order at the next one dot equals condition on the one right after it, right? Oh, sorry, one before it, sorry, because this is checking to the behind it, sorry. So for this condition, we're going to, if this is the case, then we're good. We're free to go. We don't need to check anything else, right? We have the same idea here. If I is less than current order dot length -1, as in it's before the last one, that means we can check the one right after it. So we're going to do current order at I dot equals our condition at 0. That's the first cow. And our current order I dot equals, this is I plus 1, sorry. Right, we're checking the next cow in the order to see if that's a thing. That's also a return true condition. Now, if we go through the whole thing and we never find any of this, that's a fail on the condition, right? So it's really nice to just having this function because we're going to go over here and we need to check every single one of these conditions. Okay, so we do need to check for every single one of those conditions. Let's go ahead and check for every single one of those conditions. So we're going to go through, I'm going to show you guys a very special for loop. And I want you guys to read it a certain way. I'm going to put it on the side as well. But if you guys see this, I think this is going to make a lot more sense if you read it out loud. I'm going to write this for loop. Now some of you guys might go, I don't know what that for loop is, right? Read it like this. It literally reads to for each condition in conditions, right? Now a single condition is a string array. So just that's why it's string array condition. For every string array condition in your conditions, just read it out loud like that, and it should make more sense. All we need to do is just check condition of our current order and this current condition, right? We just check if this condition works, okay? We can actually return, oh shoot, we have to check if it fails. So we do actually have to flip the reverse. If the current condition works, we can move on to the next condition, right? So having it work isn't as useful as having it not work. It's one of those things where you do search algorithms, sometimes you just do the opposite. I do go over this in my class. So let me know if that's confusing again. The thing is we check for the opposite. We say oh, is that condition false? Because if it's false, then we have information right away. This whole thing will not work. So what we can do is we can return remember what I used the trick over here as well. If it's null, then this doesn't work. So we're going to return null here. And yeah, if we go through the whole thing and we never returned null, that means every single condition worked. So we can actually return the current order that is unchanged. And because it's not null, it's never going to run this code over here, which means our current order should be fixed. If this whole thing runs and we never return current order, that means that this thing is actually impossible to match the conditions. That condition is absolutely impossible. So we're going to end up with return null, which I don't think that's possible because we are checking every single permutation with this. So yeah, okay. All right, so I know that was a lot. There needs to be a lot of re-explaining to it, but there's a reason why this is being recorded. Sounds that. But let me go ahead and finish this up. It's really simple. We can just check the order that we care about, which is permute current order. 0 is our first condition. Oh, sorry. For our current order, it's not current order. It's a completely new string. By the way, this is actually this right here. We're just putting that right over here. It's going to be a completely new string, which is the same thing as cows.length. Sorry about that. And we're going to pass in our conditions. Sorry, 1 second. Someone's trying to call me. Okay. So let's go ahead and finish this up. We have the order that we wanted. I think the only thing we need to do is create our output file now. So she needs to really stop messaging me. Give me 1 second. Let me mute her for a second. Can I mute that? Yeah, okay, so she's muted. Sorry about that. Someone's trying to spam me. Okay, so let's go ahead and this is really simple. We just need to create our file. I like to use print writer for this. I don't know what you guys use. It just basically lets me do system.out stuff, but through files. That does have a few things to memorize. You need to put a buffer writer on a new file writer. What was it again? Lineup. Out. And then we can do for loop throughout the order. Close. Let's go ahead and test this. This is our lineup.in. Let's go ahead and run it. And I think that's correct. We can actually double check. Beatrice, Sue, Belinda, Bessie, Lou, Bella, Buttercup. Yes. I can submit this. It'll be kind of awkward if it doesn't work. But I think this is gonna work. I'll go ahead and submit that. And let me pull up this next part while we're doing that. So yes, I know that was recursion. And I know that was really complicated. But don't worry, this was a very confusing topic to me too. I want you guys to, well, it was permutation. Permutation was really confusing. But if you guys just spend some time doing it by hand, if you guys are working on the solution, I recommend that you guys just do this ACSL way. You guys are used to the ACSL stuff, so I'm pretty sure that's kind of okay for you guys. I want to do something that feels regular for you guys while feeling, I don't want to do anything that's too overwhelmingly difficult. So hopefully that was that, but yeah. Of course, you can ask me any questions outside of class as well. Anyways, let's move on to mixed milk. And I will be posting all the code and the easier versions as well about permutations as well. You guys should take a look at those. Those are really cool. But I am going to move on to the next one here. This one, again, is really simple. There's only 3 buckets of milk. I think the only thing to really get used to is the idea of pouring out the milk to another thing, right? So if you guys aren't sure what the problem is talking about, Let me just fill you in real quick. This is how much the bucket can hold. This is how much the bucket has, right? For each of these 3 different buckets here. So if this one has 11 and this one has 4, if I poured bucket 2 into bucket 3, this would now read 11, 0, and this would now have 9. Right? So hopefully that's not too confusing. Excuse me. The code for this is actually really simple if you understand this sort of principle about pouring, right? Let's say this bucket is talking about like capacity. So this is like 100 or something, I don't know. And then this is another bucket, and we want to pour the left bucket into the right bucket, right? So this is bucket 1 and this is bucket 2. And let's say we want to pour bucket 1 into bucket 2, but this one is filled up about here, and this one is filled up about here. Okay, let's just say for a test example that it was something like this. We're just trying to pour this in. If you think about it in terms of pouring, I think that's a little bit difficult to program. But so I kind of want to simplify this to you. All we need to do is figure out how many we want to subtract from B1, right? And that is also the same amount that we need to put into B2. So let's just kind of use a little bit more mathematical. I'm sorry for delving into the math a little bit, but we're going to specify some kind of amount, right? And this amount has to be the same that we take out from B1 that we put into B2. So B1 minus equals amount, and B2 plus equals amount. That's all we need to do. So all we need to do is figure out how much is a good amount. We want a good amount, right? The amount that kind of implies that we're pouring. And remember, the way the pouring works, again, if you haven't caught up with the problem, we want to pour as much as we can to fill up the next bucket, or unless we run out of milk. Okay, so how do you determine this? Well, there's really 2 values that you need to check for emptying out and filling it up. And that's the amount that you need to empty out and the amount you need to fill in, right? Really, all you need to check for are these values here. How much milk is on this one and how much space is in this one? I mean, think about it, right? If you're trying to fill up like a trunk or something and see, does this thing fit? Does this thing fit? What would you do? You would check how much room is there, and you would check how big this thing is, right? And say, well, does it fit? That's all we need to check. How much of this is here and how much can fit? As it turns out, here's a little nice thing that I like to use a lot with these things in USACO. You can actually get the minimum between whatever B's amount is, right? B1's left over or something, I don't know. How much is left over? And you can compare it to B2's, how much space is there? How do you compute the space? Well, that's just the capacity minus the amount is left over, right? Maybe that's not a really good term to use, but you get the idea, right? If you actually get the minimum between these 2, that's how much you should actually be putting in. And that's how much you will actually be taking out from B1, as well as putting into B2, right? We can also think of another scenario. This is a different scenario where the other way works, right? There's too little milk, but there is way too much space, right? This is obviously going to fill up all the way. But as it turns out, we're comparing this whole value with this one, right? There's really only 2 scenarios for this, and those 2 scenarios are actually easy to figure out. So all we need to do is just compute this, and we're kind of just done with this problem. Yeah. Now, again, for catching, I'm gonna kind of explain the problem one more time. You do have to do this 100 times, 100 pour operations. So what that means is we pour bucket 1 into bucket 2. That's one operation. Bucket 2 to bucket 3. That's another operation, right? So what I'm going to do is I'm going to pour bucket 1 into bucket 2, pour bucket 2 into bucket 3, and then do that 33 times. Does that make sense? That way we get 99 different operations. And all I need to do is just do one more operation of bucket 1 to bucket 2 at the very end. Basically kind of how they explain it over here. You're going to see me do that right now in just a second, okay? So if anyone has any questions, again, chat is open. Okay, let's go ahead and get started here. I know I'm typing intentionally fast because the source code will be given to you. So let's go ahead and read this file. Go ahead and create it again. Oh, sorry, it's not system.in. Wait, is this system.in? I have to remember, some of these are system.in, so. I did this problem. I didn't know it's not system.in. Okay. So we're gonna read these. Now, what's really, I think the best way to go about this is instead of doing some kind of crazy data structure, right? We've talked about there's really only two pieces of data, the capacity and the amount that's left over. I'm just going to call them, and I'm going to use the language that they give me over here. And you guys should kind of get used to that too, using the language that they give you here. So we're going to use C1, M1, C2, M2, C3, M3. Okay. If you guys can come up with better names, please do. But because this problem just kind of uses these letters, it's okay to do that, right? But when you guys are normally programming, I always emphasize use better variable names. Anyways, let's go ahead and just fill those in. This is really easy. We can just do in.nextInt. And we can kind of just copy and paste this 6 times and just change the variable, right? Next int. I don't know why I put next line. Next int. Do this 6 times and just start putting 2s on these and put 3s on these. And then every other one, just put an M on it. And there you go. Now I fill up every single one of those. That's what we're working with. Cool. This should be pretty straightforward. I'm going to do a little in.close because those are all the variables that we need. Okay, let's go ahead and do the 3 operations 33 times. So that's a for loop running 33 times. Right? It's a simple formula. Just put 0 less than 33. That gives you 33 times. And what we're going to do is we're going to pour M1 into, we're going to pour bucket 1 into bucket 2. Okay. And all you do is, again, calculate the amount. That's math.min between M1 and C2 minus M2. Right? If you want the picture for visual again, here you guys go. Whoops. Here you guys go over here. Right? The amount is just the amount that is in bucket 1, and then the total amount minus whatever's in amount the second one, right? Which is basically this over here. It is encoded in code, so I'm just showing you the parallel. Okay. And that's all we do. Now, all we need to do is now subtract it from the amount in M1. That's M1 minus equals amount. And then we got to put it into M2, M2 plus equals amount. Okay. And now you'll notice that this process kind of repeats 3 times, but for M2, M3, M3, M1. So we're just going to copy this amount part. And this requires you to a little bit of concentration, but as long as you're just being careful about it, you should be fine. Change the M1s to M2 and then the following ones to 3s. Change this one to 2 and this one to 3. Change this one to 3 and this one to 1. This one to 3 and this one to 1. Make sure you don't make a mistake because it's kind of hard to debug this actually. So just be careful about that. Okay. Now, even though we finished this, we do need to do this one more time because it is 100 operations. Just copy and paste that. I don't think there's really much else to do with that one. And yeah, all of our things should now be in M1, M2, and M3. That's what they want for your output. So we can go ahead and start doing our stuff. What can I think? Buffered. Forget to mix milk out. Okay. So all you do is just out.println M1, 2. Close. Yeah, we can just go ahead and run it. Okay. Should get 0, 10, 2. Go back over here, go into mixing milk. We can actually submit it if we want to. Yeah, that's actually the same exact code I think I have. So I don't really need to check it now. So that kind of finishes it up for us. I want to do a quick review and talk a little bit about time complexity because that is an important subject. And talk a little bit about the algorithm that I did. Okay. Let's just check this grading thing. And I was talking a lot. Again, review the video. I will be giving you guys these stuff, okay? Let's go back to lineup real quick and recall that it's really nice if you can actually check every single ordering and just check every single one of those. It'd be really nice if you can do that. And we can. That term is called permutation. Okay. Now, the way permutation works, okay, is this part gets a little bit tricky here. File new, don't save. I want to talk a little bit about the permutation time complexity. Because let's say you had 5 different objects, A, B, C, D, E, and you wanted to do the permutation of that. Well, you can imagine that we're reordering. We have 5 different slots, and we're kind of putting them in any order. So the way it works is actually a thing called the fundamental or the principle of counting, the law of fundamental counting. I don't know. I can't remember the name. But the idea here is there's 5 different positions that we can put in here. So we're going to put a little 5 under there to indicate that there's 5 different things that we could put in here. We could put in A, B, C, D, or E. On the next one, we cannot put whatever we put over here. So we actually end up with 4 possibilities. And on the next one, there's 2 taken up by the 5 and 4, right? So we actually end up with 3, 2, and 1. Okay, so here, let's say if we put A, that leaves us with B, C, D, E, giving us 4. If we put in B, that leaves us with C, D, E, right? So those are all the different ways that you can do this. If you want to calculate how many possible permutations you multiply all of these straight through, and that's how you do it, right? Now, for this version, there's 8 different things that we need to permute through, right? And because there's 8 different things that you need to permute through, that is going to be 8 times 7 times ... which we call 8 factorial, okay? If you don't know what 8 factorial is, it's literally just this. Anything factorial, with this is a little exclamation mark, is it's going to go down by 1 and it's going to multiply it to that number, right? It's kind of like a for loop, but decreasing. Let's compute 8 factorial. Let's see how bad that is, right? We're going to do 8 different factorial. We're going to check 8 factorial different combinations. How bad is that, right? We're going to at least run something 8 factorial times. It's 40,000 times. But we're not just doing something 40,000 times, because for every permutation that we need to check, which is in this if statement right here, this is the finished part of that permutation. For every single one of those, we end up with a whole different set of conditions to check. How many conditions are there? Let's look at the worst case scenario over here. The worst case scenario is 7 different conditions or constraints, as they call it, right? So not only is there 8 factorial permutations, for each of those permutations, right, whatever this value is, we're going to multiply that to each of those 7 things. This is another 7 things to do for each of those permutations, right? So what is this number? Let's multiply that out. Go ahead and pull out a calculator or something. You get 282,000 different steps. And you're like, oh, that's so much. Actually, it's not that bad, right? Because again, the condition, the rule of thumb, the standard is 10 to the 8. The reason why this works is because the standard is 10 to the 8. If you're not sure what 10 to the 8 means, right? It just means basically a 1 with 8 zeros after it. That's a 10 to the 8. So if it's something like if your number is starting to get about this big, then you should start worrying a little bit. It doesn't mean you shouldn't try it. I definitely think you guys should try the worst case scenario, the easiest case scenario, right? But if this doesn't work, you should start looking for a different kind of algorithm. That's when we start looking for efficiency. But otherwise, we can totally submit this and it works, which we did. It's fine, right? There's only 6 different digits. This has 8 different digits, right? This is totally fine. You might be wondering, well, what about this one, right? Well, this is actually going to do just 100 different operations. Technically, it is 33, I know, but even then, it's just 100 different operations. Like if you use this kind of idea here, sorry, if you use this idea here, it's just 100 different operations. That is even smaller than this by a large amount, right? So you can assume that the time is even faster. So for the time complexity of these things, it's not so bad as you might expect. Okay. But permutation does get really, really big. So don't just resort to permutation. We're at 10, we're at 8 factorial. Let's check out 9 factorial. Right, just 9 factorial. We're not going to multiply the 7. And it starts becoming here. Oh, that's an interesting movie. I don't think I saw that. Then we get to 10 factorial, and now we're at 10 to the 6. Then we get to 11 factorial, and we start getting into 10 to the 7, right? There's 7 different digits. Count those up. Then we get into 12 factorial, and we end up with now we're way over the limit. So if you're doing factorial, we like to keep it like 10 or less. So if you're doing something that's going to do a permutation, you better be permuting through 10 different things at most. That's around okay, I think. Just a little tip on permutation there. Anyways, hopefully that was help for you guys in terms of understanding permutation. That is a very important concept. You guys should also look it up on the USACO.guide website. They have a pretty good information about that, but I know you guys don't like reading. I think you guys would prefer doing something like this a lot more. So I will just upload this. I want you guys to really try it by hand or do something to help you understand this, right? I will upload some other pieces of code. You guys can try the other codes too if you think that's going to be easier to understand, right? But I really want you guys to sort of understand the recursive version, okay? Also, a quick side note, there is a non-recursive version of this, which involves just using a bunch of for loops. I already mentioned this before. But again, that also depends on the if available thing. So you do have to have a bunch of if statements inside of those for loops. But aside from that, I think that's pretty much it. Okay, so I will conclude that with that. Hopefully that was good. I'm gonna stop the recording here and start uploading stuff. Actually, does anyone have any questions? Anyone have any errors or anything? All right. Is everyone just typing up their question right now? Should I give it? I keep forgetting to give my students more time to type stuff. Let you guys type some more stuff. The code is going up right now. And don't just copy and paste it and expect it to work. Oh, I'm sorry. Hold on, maybe I should just upload this as a file. I really want you guys to build the intuition for recursive stuff. I mean, permutation stuff. Where did I put this again? GitHub, USACO temps, bronze, and then lineup. 2019 lineup. And one more. Mixed milk. Okay. Otherwise, I will stop the recording here. Thanks for listening. Excuse me, participating. Yeah, good luck on your testing stuff and enjoy your break if you guys have it.